It's like snail's pace.
You make money off YouTube.
How do you make money?
I think yesterday you had a station I want to subscribe.
One of your
I don't think I
videos
have
has
enough
like
things there to
10,000
make
views,
money.
and then you can apply for
Sure.
linearization.
10,000 views every time I watch it.
Everybody in the school watches it.
Hey, where's my book? Who put my book up there? And then we also have to go over, I also want to discuss one problem. Well, I don't know what we're going to have time for today. So 5.5, linearization. All right, number 2. So this is like the example I gave yesterday. You know what? I'm just going to do the whole thing. F of x is equal to the square root of x squared plus 9. Okay, write the a equal -4. So what they want you to do is write the linearization means write the equation of the tangent line. Do not use the formula printed in the book. You can if you want, you're going to get the same thing. So if the x coordinate is -4, what's the y coordinate? Plug it in and you get 5. How do you figure out the slope? You take the derivative. So this is like to the 1/2 power. So 1/2 box to the -½ times the derivative of box. Do not forget to multiply by derivative of box. It's gonna doom, doom. Okay, so if I plug in -4 into the derivative, what is the slope? 16 plus 9, 25 to the -½ 1/5 times 4, Oh, -4 fifths is the slope. So y minus 5 equals -4 fifths times x plus 4. That is the equation of the tangent line. What did I tell you to do yesterday? Move the 5 on the other side. So y equals 5 minus 4 fifths x plus 4. So that is called the linearization of this function at this point. Now, part B says, how accurate is the approximation if you add 0.1 to this? So, but then in my homework, didn't I like change it? Where's 5.5? Number 1a. Oh, 2a, look, 2a. It says use your result to estimate f of -3.8. So instead of plugging -3.8 into here, into the original function, it's hard to do without a calculator. You plug -3.8 into the line equation. This is exactly what you're going to do on the AP exam. And that's why you keep it in this form now. Keep it in the point slope form. Do not distribute the -4 fifths. Because look how easy this is. What is -3.8 plus 4? 0.2, which is 1/5. What is 4 fifths times 1/5? Here, I didn't write it then. What is 4 fifths times 1/5? Actually, on the AP exam, that would be full credit right there. However, on my exam, I expect you to simplify. Okay. So 5 minus 4 25ths. And what is 4 25ths? You want to change that to a decimal? Okay, never mind. Let's just write it 4 and 21 25ths. What do you mean, huh?
Oh.
Come on, this is fractions. This is elementary school. Let me ask you this. What is 1 minus 4 25ths? Isn't it 21 25ths? Oh my goodness. So this is a good approximation of the square root of -3.8 squared plus 9. And did I tell you yesterday why it's a good approximation? I'm going to tell you again. So if you were to draw this graph, when x is -4, we wrote the equation of the tangent line. So here's -4 right there. See, that's it. -4. -3.8 is over here, yeah? -3.8. Going up to the graph. Can you see that the y coordinate on the graph and the y coordinate on the line are very close? So when you are close to -4, this is going to be a good approximation of that. But you have to be close, because can you see that when you go farther away, see how the error is a bigger error? So you have to be close. In fact, some of the problems on last night's homework didn't ask you to find the percent error. For those of you who looked at the homework problems.
You said once it's tall if you're asking.
Oh yeah. That's the next thing. But so before we move on to that, do you guys know how to compute percent error? Because I think twice you have to do it in last night's homework.
No.
Probably I'm gonna check that if I'm gonna check any problems on the homework, I'll check that one.
It's 62.
Just one problem only.
Yeah.
Oh, but you gotta do it, right?
Yeah.
So now I'm checking then. Oh, but you got it right there. Anyway, come on, you guys can take science since 9th grade when you made lab reports. Did you have to find percent error?
Yeah.
Biology, chemistry, physics, you all have to find percent error. So how do you do it?
Experiment.
Compute, what did they call it? Experimental minus the actual. Now what is the actual if you plug in negative 3.8 there? Negative 3.8 squared plus 9, that's the actual, right? Whatever that is. Divided by the actual times 100 to change it to a percent, yeah? That's how you get the percent error. But you don't have to do it, this problem, you're gonna have to do it in 62. Okay, and then it says determine whether it's an under or an overestimate. Now, how can you tell if the point on the line is either above or below the actual point on the curve? What determines whether you have an under or an overestimate? The concavity of the graph. See how when the graph is concave down, see how the point on the line is above the curve? So if the graph is concave down, you're going to have an overestimate because the point on the line is above the actual point on the curve. However, if the graph is concave up, see how the point on the line is below the actual point on the curve? Then you have an underestimate.
So can we just say that?
No, but you have to show the concavity of the graph. So, do we have to do that for this problem?
No.
No.
Yes, it does, right there, 2A. Determine whether you have an under or overestimate.
Oh, yeah. Just say it's over under.
Yeah, but you gotta give a reason. The 8, 5. Okay, so what tells you the concavity of the graph that we learned this chapter? The second derivative. So here,
Oh, that's why.
Wait.
you cannot just say, oh, I think the graph looks like that. You're not gonna get points on the AP exam. No, or I think the graph looks like that. No, you gotta look at the second derivative. Oh my goodness. Okay, here, let me rewrite the first. Let me rewrite the first derivative. Here's the first derivative. We cancel out the 2's. You got x times. That's why I made you guys do it for homework. Mr. Parker never did it. Okay, well then you better understand what I'm doing here. Everybody agreed that's the first derivative because I canceled out the 2's. Now you gotta compute the second derivative. Well, I see a product. I'm gonna use the product rule. Derivative of the first, leave the second one alone. Plus, leave the first one alone, and then negative half box to the negative 3/2 times the derivative of box. There's the second derivative. So what we need to do is we need to compute the value of the second derivative at what point? Negative 3.8 or negative 4? It's negative 4. Because because I'll tell you right now, I don't think you guys can plug in negative 3.8. It's negative 4 because that's where you wrote the equation of the tangent line. So at that point, we need to know whether the graph is concave up and concave down. Not at this point, at this point there. So whatever point is given, that's what you figure out the concavity. So what you need to do is plug in negative 4 into the second derivative and see if it comes out positive or negative. Now on the test, because every year there's always students, they just go, they look at it and go, oh, I think it's positive, or I think it's negative. No, you gotta come up with an exact number. You're gonna have to do arithmetic. Okay, let's see if we can do this. Plug in negative 4 here. 16 plus 9, 25 to the negative half. 1/5. And then over here, again, the 2's cancel out. So basically you got x squared, yeah? So what is negative 4 squared? 16 times 25 to the negative 3/2 power. Now, what the heck is 25 to the negative 3/2 power? 1 over, you square root it first, and then you cube it. 125. And then you make a least common denominator, so that's going to be 25 plus 16, which is 41, what? Where's minus?
Because it's negative half.
Yeah, right there, minus 41, 25 minus 16. Why am I rewriting it again? 9 over 125. So that's, I want to see that number on the test, you know. That's okay, it's only going to be 1 point. If you want to sacrifice that 1 point, because most of you, right at this point, or even at this point, you can say, hey, that's a positive number, yeah? But on my test, I want to see the number for 1 point. So this number is greater than 0, which means, what does that mean if the second derivative is positive? This is what they want on the AP exam. This implies f is concave up. Now this must be mentioned in your explanation. If this number comes out negative, that implies f is concave down. So if f is concave up, what does that mean? Draw the picture if you have to. Concave up, the tangent line is below the curve, so therefore an underestimate. Okay, I'm telling you right now, this problem is on the test. It's on the practice test. You got to do all three of these things. Write the linearization, get an estimate. I'm not sure if I'm going to ask you for a percent error. Maybe I will. I did it last year. Maybe this year I will. And then this one for sure. Is it an under or an overestimate? Because they always ask that on the AP exam.
Wait, how do you know if that's what the graph looks like with the line under?
Because the second derivative came out positive.
Oh.
Positive means it's concave up, right? If the graph is concave up, and then you write the equation of the tangent line, the line is below the graph. See, the point on the line, which is this number here, is less than the actual point on the graph. Yes?
If you give us percent error, don't we?
Yeah, I'll let you use it for that one problem, just to see if you can punch it in.
Wait, so how
Come on, you guys can punch that in on your calculator, can't you? Maybe, maybe not. I don't know.
How come we have to do the whole second derivative thing where we can just look at the value? Because that's less than 5.
No, we don't know what is the actual value? Okay, if I plug in negative, this is the actual value. This is the actual value right there. No, it's not 5, it's that.
Oh no, of 4. Like negative 4.
No, but you're not doing that, because now we went, see, here's 4. We want the value at negative 3.8. So tell me, how do you know this one's bigger than that, or that one's bigger than that? Some of you try to do it in your head. Okay, negative 3.8 squared. I give up already. No, you cannot. You cannot. That's why you have to look at the concavity. Believe me, you cannot. You cannot. You're not going to be able to do it in your head. No can. That's why you got to look at the concavity. And even if you did know on the AP exam, they want you to say this. The second derivative came out positive. Therefore, f is concave up. Therefore, it's an underestimate. That's what they want on the AP exam. And don't worry, in the fourth quarter, we're going to go over like every word that you have to say to get all the points.
I was gonna ask you something.
Okay, what? Something serious?
No, about something you just said this.
That's unfortunate.
Yeah, serious.
So what is it? But maybe I can remember it here.
It's on video.
No, just tell me. So what is it?
How did the I'll just ask you later. This is sorry.
Just ask me later.
Yeah.
Okay, we're moving on because maybe it's going to be addressed in these other problems here. Yeah. No, because I have to erase because when we film, we only can do one side of the board because you can't. Both sides can't fit in there. 59. So this is usually, you're going to have 6 free response questions. This is going to be usually 1 free response question right here. 59. What?
It's number 1.
I'm giving you a boo here.
Okay.
What is the linearization at x equals? Linearization means write the equation of the tangent line. Come on. If x is 1, what's the y coordinate? Plug it in and you get, okay, how do you find the slope? You compute the derivative. What's the derivative of e to the x? E to the x. Okay, plug 1 into the derivative, and you get e, then point slope kataize it. Y minus e equal e times x minus 1, and now pick out the answer. You guys can you guys pick out the answer? Okay, I'll pick it up. Some good. No, what do you mean no? Okay, now look at what they do. They actually solve for y. That's, I don't like, whatever. If you have to do extra work, you do extra work. E x minus e, the e's cancel out. Y equal e to the x. Okay, now can you pick out the answer?
Yeah.
Or do I have to look?
No, it's
Okay, oh, look, too
B.
late. I'm
It's
looking
B.
at it. Don't.
Oh.
That's just B. That's just B. Come on. 62. Okay, this is the one where you have to find percent error.
Yeah.
We're in trouble.
Yeah.
Okay, y equal the cube root of x at x equals 64. So it says use linearization to approximate the cube root of 66. What is the percent error? Okay, well, let's just do one thing at a time. How do you write the linearization? Just write the equation of the tangent line. So 64 comma what? Plug it in to find the y coordinate. 4. How do I find the slope? You take the derivative. So that's like x to the 1/3. So 1/3 x to the negative 2/3. And here's the hardest part for you guys. Plug in 64. Cube root it, and then square it, and then go 1 over it, and then times it by 1/3, and you should get 1 over, okay, 48. That's why you have to take algebra 2 before you come here. Otherwise you can't do that. And then now just do point slope. Y. Now, for those of you who did your homework, you guys know already, right? Should I write y minus 4? No, because we can put the 4 on this side, remember? So then you just plus 148 x minus 64. Okay, never mind. Just write y minus 4 and then add 4 and you get this. Okay, now they want you to approximate the cube root of 66. So instead of plugging 66 into here, you plug 66 into the line equation. So that's easy. That's why you leave it in point slope form. What is 66 minus 64? 2. What's 2 times 1 over 48? 1 over 24. So the answer is 4 and 1/24. That's a good estimate of the cube root of 66. How good? Well, that's what you have to find. Find the percent error. So how do you find percent error? Experimental minus actual divided by actual times 100. Well, you know what? Maybe I don't need you to punch it in on your calculator, but you could write that on your paper at least, right? No, I want you to punch it in. Anyway, this is on the this is an actual problem on the AP exam, so you need to punch it in, and I don't have my calculator. I will let you do it, and you guys can pick out the answer. You sure? Stake all the money in your wallet on it.
Yeah.
Okay. The answer is A then. Is that right?
Yeah.
So 0.01%. You're within 0.01% of the actual answer. Isn't that darn good? Yeah, it's very good. That's why linearization is such an important tool. In fact, how many of you are taking AP Physics C? How many of you are taking regular AP Physics? Or took it? Then you guys know, right? Okay, did your teacher ever mention this? For small values of x, sine x is approximately x.
Not now.
No.
What?
Okay, I think this would come up when you guys did like the angle of incidence equal the angle of reflection.
Or like physics.
Oh, pendulum? Oh! She said you guys did it during the pendulum.
What thing where we had to find like the forces of
You know why you guys just cut, when you guys did the lab experiment, you guys just copied off somebody else's one. That's what happened. Can I see your lab? Oh yeah, I got it. That's what happened. Anyway, now you can understand. And when you go to college, this is going to be important, you know. You know why this is true? Because it's linearization. Okay, let me ask you this. Here's the function. Write the linearization of this at x equals 0. Let's just do it quickly. When x is 0, what's the y coordinate? 0. How do I find the slope? You take the derivative. The derivative of sine x is cosine x. Plug in 0 into that, you get 1. Now do point slope form. Y minus 0 equal 1 times x minus 0. Isn't that just y equal x? See? That's why. Because look at the graph. Here's sine x, it looks like this. And then here's y equal x. For small values of x, that means near here, can you see the two graphs are almost identical? That's why it works. So that means sine of 0.1 is approximately 0.1. And I'm pretty sure you did that in the lab.
Really?
You know, I'm going to speak to Mr. Hyder about this. Huh?
He's in
Oh yeah, he's in like New York using the search or something.
New York.
Oh, yeah, for what?
I don't know.
Triple.
Really?
Yeah.
Did he have something in school?
I think he had a heart attack.
In school?
What's it?
Okay, I'm going to ask Dr. Okay, that's Dr. Noy or the other doctor. There's
Dr. Lindsay?
Dr. Lindsay.
He's on too.
Because I'm the one like taking care of
No,
parents.
she had an Emmy though, and your Emmy is like a.
Okay, I'm going to ask Miss Chen.
She's
No.
also
She was on the math team, you know, when she was here.
Oh, really?
Yeah.
I got it.
But she's on
maternity.
yeah.
I'll ask Doctor.
That's good.
Mr. Kohara, there we go. I'll ask Mr. Kohara.
That's
Yeah, who's that teacher that's down there in Mr. Hyder's room?
Mr. Van Kirk or Doc now.
Doc teaches Hyder's class, right?
Yep.
Okay, I just don't know things.
like three new physics teachers. Like.
All right, so do we have a firm understanding of linearization? You're only going to have one problem on the test on this, but you got to do all of these
That's
things.
bad.
And I'm debating whether to give you percent
No.
error too. It's easy, percent error, come on.
He's on the practice.
It is on.
There's a percent error?
Oh, never mind.
I don't think there's a percent error, but I'm thinking of putting that in. Come on, you guys did it on the homework, or at least you copied it off the board. Yeah.
If it's concave up, does it mean it's under?
Yes, because look, don't guess, draw the picture. If f is concave up, the tangent line is below the actual graph, right? So the point on the line is below the actual point, so it's an
Also,
underestimate.
the first one is an underestimate.
I don't know.
Yeah, it is.
I think it is.
Okay. You know, I was thinking of something when you said that. I don't remember what it is already. That's what happens when you get old. Okay, before I pass back the test, okay, there's one other problem that you need to know because this problem is on the test. I'm going to give you the graph of the first derivative, and you have to sketch the entire function. No, it's not that hard. It's not that hard, believe me. Okay, so here, I am going to give you the graph of the derivative. Okay, 1, 2, 3, 1, 2, 3. And since we're AB, it's not going to be that complicated.
Yeah, it's part of homework.
Yes, it's on the practice test. Tonight's homework. You guys know where the practice test is? On the left-hand column. I think it says max, min, point of inflection, linearization, review worksheet. I think that's what it says. Okay, so I'm gonna make. I want to make sure it's different from the one that the. Woo! There you go. This is the first derivative. This is not the original function. This is the first derivative. Based on this, I want you to sketch what the original function looks like. What? Well, go back to what you know. Number lines. Okay? So what we're going to do is we're going to make a number line for the first and the second derivative. If you did, in fact, one of the homework problems, didn't you have to make a number line? Remember? You guys maybe do it on the board yesterday. Okay, but now you're going to do it for real. Okay, here is your first derivative. It's like you graphed it on your calculator. Here you're looking at your calculator. Where does it touch the x-axis? Negative 2, 0, and 2. It's above, below, above, above. Right? What do I need to write underneath? F is in, okay, if you have a legend, you can go F is increasing, F is decreasing, F is increasing, and then F is increasing some more. So tell me, what do you have when x is negative 2? Is that a local max, a local min, or neither? It's a max, because look, if it goes up and down, it's like the top of the hill, right? What about at 0? You have a minimum, and what about a 2?
None.
You don't have anything. Because if it goes up, and then you go up some more, that's not neither a max nor a min. So just because the derivative is 0, that doesn't mean you have a max or min. Like right there, that's neither a max nor a min. That's why you need to make the number line. Okay, now that's easy because you're just looking at that and making a number line for it. But now, you need to make a number line for the second derivative. And I would highly suggest you do it like one on top of the other. So, if this is the first derivative, what is the second derivative? It's the slope of this graph. So the first thing you look for is where is the slope 0 or doesn't exist? There, there, and there. Those are the things that you put on your number line. So where does this happen? -1, at 1, and then at 2. You're trying to line them up. Now, how do you fill in the signs? Well, if the graph is going downhill, what can you say about the slopes? The slopes are negative. So you're making a number line for the slope of this graph. Now, what about between -1 and 1? What, if the graph is going uphill, what can you say about the slopes? They're positive. So if the graph is going downhill, then you put minus. If it's going uphill, you put plus. What do you need to write underneath it if you want full credit? No. F is concave down. F is concave up. F is concave down. F is concave up. If you have your legend. Okay, now we need to sketch the original function. Let's do it in a different color. You don't have to. On the test, I'm going to give you this. I'm telling you what's on the test. It'll be a very similar graph, and then I'm going to ask you to sketch the graph on the same axis. So you don't even have to draw your own axis. Now, since we don't know what the original function is, we don't know where to start. So you can start anywhere you want. Where do you want to start? Tell me when to. Some people might start up here, some people there. Anywhere you want. Why don't we start right there? Follow your number line. Just go unit by unit and follow the number line. From -3 to -2, what's happening? Increasing, so uphill, but concave down. So you have to draw something that's going uphill, but it's concave down, so like this. Now, some of you might draw it like this. Some of you might draw it like that. It's all the same thing, it doesn't matter. It has the property of what's supposed to happen. You guys understand? Because you cannot draw the exact graph. Okay, now what about from -2 to -1? Look at your number line. Between -2 and -1, what's happening? Decreasing, concave down. So how do you draw a graph decreasing and concave down? Or if you want to, you can go down further. It doesn't matter, as long as it's decreasing and concave down. Now what about from -1 to 0? Just look at your number line. Decreasing, concave up. So decreasing, concave up. In fact, see how it's decreasing and concave up like this? What do you guys call this in economics when the graph looks like this? It's decreasing at a, who takes AP Econ here? Okay, then you guys should know. Like if the graph looks like that, Mr. Suzuki says it's decreasing at a decreasing rate or decreasing at an increasing rate. See, you guys are getting, okay, look at this one. You guys are confused because it's negative. Okay, let's look at this one because this here, it's increasing at an increasing rate or is it increasing at a decreasing rate? Look at the slopes. Are the slopes getting bigger or smaller?
Smaller.
So it's increasing at a decreasing rate. That's what you guys say in econ, right?
No.
But in calculus, we just say it's increasing and concave down. That's what we say in calculus. Okay, let's continue from 0 to 1. Look at your number line, 0 to 1. What? Increasing, concave up. So, whoop. Okay, what about from 1 to 2? Look at your number lines, between 1 and 2. Increasing, concave down. So, whoop, like that. And then finally, if from 2 to 3, increasing, concave up. Whoop. So as long as your graph looks something like that, you can get full credit, but you gotta also have the number lines as well. If you don't have the number lines. So some of you might have, you guys like pronounced curves, that's why, yeah? So your graph might look like this. That's okay, that's full credit. Or some of you don't like pronounced curves, and then you go like this. that would be correct as well. You guys understand what I'm saying?
Yes.
Do you draw arrows on the ends?
No, no need, no need.
Just
As
the-
long as you have that full credit right there.
Oh,
So you got one on the practice test, so make sure you practice it. Okay, we only got 10 minutes left. Let me pass it over. Okay, so I decided, you know, yesterday, as of yesterday, I was gonna just give you back your worst problem. But for, oh wait, I gotta turn this video off. We can't have us going over the test on the video. What's gonna happen